hello everyone. Can you hear me well? Yeah, all right. Thanks, James. All right, good morning. I know it's been like a long session, so I'll try to mix it up a little bit. But I'm guessing most of us in the room have had a wow moment with one of these coding assistant tools. You give it a simple prompt and it can generate the entire function for you. And in that moment, it feels like an incredible productivity boost. But a week or so later, when you're debugging an issue in production, you realize it's actually pointed to that AI-generated code, which looked right in that moment. It did the right thing, but it missed a subtle edge case, or it was using an outdated function. In that moment, you realize that when you had hit that tab and accepted that code change, it became your code and your responsibility. So with this new paradigm, we are dealing with a new relationship. We understand that it's not just an autocomplete, it has a brain of its own, but at the same time it has its own blind spots and really no real sense of accountability. So learning how to manage this new reality is something that I do with our teams and our clients, and I hope to bring you some insights on how you can get the magic of AI without the mess. So let's get started. Let's look at the central paradox that many organizations and teams are facing right now. On one hand, the raw capability of AI is increasing exponentially, right? We are seeing research that the complexity and the length of task AI can perform is actually doubling every 7 months. However, when we look at on the other side, when we look at the productivity gains, and this I mean like your business value, your outcomes, the picture is very different. Recent studies show that organizations are only seeing a 5% productivity impact by using GenAI and the tools that we have been talking about. So let's think about the gap, right? Like the technology is exploding, but our productivity is not. And this difference we need to find the root cause for it, right? What does it tell us? It actually tells us that simply exploding raw technical capability is not going to lead to actual business outcomes. We are experiencing what I like to call the sugar rush of productivity. We think that we can give our developers the right tools, our QA some tooling, and we'll be magically there in a few weeks. But what we have not done is that we have not changed our systems to be ready for the AI leap. So in 2025, actually the central question facing most of the technology leaders is not that whether they should adopt AI, right? It's about how do they unlock value from AI, how do they realize it? So Dora's research reveals a critical truth that AI's primary role in software development is that of an amplifier. So it's not a solution in a box, it's actually an amplifier. It magnifies the strengths of a high-performing organization, but at the same time, it magnifies the dysfunctions of a struggling one, right? So the great return of AI investment comes not from the tool themselves, but from a strategic focus on the underlying organization systems. The quality of your internal platform, the clarity of your workflows, the alignment of teams. And without this foundation, actually AI creates pockets of productivity, but that do not translate into real business value. Okay, so everyone has been talking about how we can use AI to accelerate coding, how can we generate more code. And AI is revolutionizing software development, there's no doubt about it, it will. But let's ask a critical question, where does a developer's time go on a day-to-day basis? The data, which hasn't changed much in the last 5 years, tells us that we only spend a percentage of our time actually writing feature code and generating new code, right? About 50 to 60% is gone in other things, like the time that we spend in trenches, getting the context, understanding what the business wants us to do, navigating general system complexity that has, we have incurred over the years, and also attending meetings, right? So making the 40% faster is a clear win, but we cannot get truly fast without focusing on the rest of the 60%. So what do I mean by that? These are just some examples of common impediments to flow, and they are not just your development or your coding related. So the first one is around finding information. Maybe a show of hands, how many of us actually struggle to find information about our coding systems, our API integrations, just our systems in general, right? Like we spend a lot of time just finding information. And there is a hidden cost of not having quality information readily available for us. What this usually sounds like when I speak to development teams is, okay, where is the documentation for this service? I was just handed this system over and I don't really know what it means. How does this legacy code work, right? Which API am I supposed to call? And this leads to, what we say a flow state catastrophe, which means I've just started development, but I'm interrupted by going and having to ask what information it is, going and checking some documentation. And we think it takes us 5 minutes, but it actually takes much longer than that. And if I started my morning getting interrupted 4 or 5 times, I have already lost my state of flow to be actually do productive development. Next, when we think about is DevX friction, right? So my local setup is broken again. The build is going to take more than 20 minutes to run. So let me, go grab a coffee or check my Slack message. The tests are flaky. Again, this wait time friction is also very critical, right? Even if I have an AI-assisted code, a coding assistant, I cannot mitigate this, right? This is a forced dead time. And it's not just 20 minutes of lost work when the pipeline is building. It's actually, as a developer, I'm forced to switch context during these 20 minutes while I'm waiting, either to go check my Slack message or either, find something else to look at. And again, this creates a lot of, inhibits the flow that we are in. Next is just cognitive overload, which I refer to as the complexity tax of any organization. So it's not just about developers, right? This is something that affects our business analysts, our quality analysts, SRE, operations, everyone, because we're just navigating the complexity that we are all in. This is your dependencies, your processes. It's the brain tax that you pay before any real value can get created. And lastly, it's about slow quality feedback loops, right? And I don't mean this in just like a long build pipeline, right? It's the days and weeks that we take to understand, okay, what is it that we want to build, the coordination between the different roles. And the most expensive loop, which we sometimes don't even think about, is the months it takes to actually get some customer feedback to know that what we have built is actually right. So with these things in mind, what I would suggest is that think about getting your foundations right. Right? So if you think of these impediments as the brake in your productivity, the solid engineering foundations are sort of your engine, right? And this brings us to a critical point for this talk that I want to share, that if you do not fix your foundational problems, AI will just help developers drive faster into a traffic jam. And what I mean by that is that we have had AI-assisted tools being given to our developers, to also our QAs, and this is like putting a car that can go from 0 to 60 in like a few seconds, but in the middle of a traffic jam, right? This car is quite fast, but because the rest of the flow is jammed, you're actually not getting any real value. So we can write code in a few minutes, but we can spend 5 hours waiting for this to get to production, fighting complexity, attending meetings, and so on. So therefore, the strong engineering foundations are almost non-negotiable if you want to see good ROI from AI. So it's incredibly tempting to see the hype and think that, okay, getting AI code assistants or testing tools for every role or developer will sort of solve our productivity problems, right? But as we have just established, the coding assistant is a local optimization, right? Yeah, it helps a developer write code faster, maybe helps you with the right practices that Venbo and Chris have shared, but it does not just do much more beyond that, right? For the impediments especially that we spoke about. That means we have to shift our focus from individual tools to systemic enablers, right? And these are the ones that I tend to usually think about and we advise our clients on. So firstly is having a solid platform engineering, right? You want to provide the paved roads and self-service that engineering teams can build, deploy, and operate their code, their software reliably. That's like a base requirement. Secondly, you want to think about DevX accelerators. You want to target the inner loop friction, right? By providing fast builds, pre-commit hooks, consistent local environments, right? Even if I'm able to generate code, if I do not have consistent local environments, I don't have a way to test, I can only get so far. Then next, you also want to think about your enterprise testing strategy, right? More quality, move quality from like your slow manual gates to fast automated signals, giving team the time for rapid feedback and also to iterate faster. Next, you want to think about domain-driven cloud architecture and enablement. So organize your systems to mirror your business domains. This really helps reduce cognitive complexity over time and enables teams to work with each other rather than cross each other in any way. Then you want to scale your knowledge and leadership, right? So you want to treat your documentation very seriously, almost like a product within your organization, directly attacking the search for information bottleneck that drains a lot of time and breaks focus. And lastly, you need to define how you work, right? Who owns what? clarifying team interactions and responsibilities to minimize the handoff delays between teams. These foundations are really what create a high flow, low friction environment. And using AI in this kind of an environment amplifies the efficiency it can unlock. Okay, so now I've given you a bit of a preview into, okay, what does it mean to get your foundations right? But now let's say we have got our foundations right. So what does it mean for us to apply AI in this context to build an effective engineering organization? So actually, AI plugs very well into the software delivery lifecycle. This is a starting point of what it could look like. So the natural starting point or the quick win that we have been talking about and the ROI that everyone is chasing is right in the middle, right? Coding and implementation. And it's a real win. Like I'm not against it. It makes development faster. It gives you good insights into how you can write code. But as we have established, that's only part of the story, right? If we only focus on that, we are missing a much larger and higher leverage opportunities, both in upstream and downstream. So let's try to look upstream, right? In the research and prototyping phase, this is a huge area for AI, right? We can see fantastic value from AI in analyzing user feedback. The lots and lots of unstructured data can now be analyzed, and you can instantly synthesize your top customer pain points. We can also use it to summarize and evaluate POCs in hours, which used to take weeks, if not months in the past. So that's a real value upstream. But even if you look downstream to testing and monitoring, it's a similar story. Instead of just writing code with AI, you can use AI to help validate by generating test cases, test data, which is usually more cumbersome to generate. And it can also assist in monitoring and observability in terms of your production alerts, analyzing your logs, to suggest a root cause instead of just showing you some dashboards, which is what we are used to today. And we will look at each of these in more detail shortly, but I think the key takeaway that I would like to share at this point is that we must think holistically, right? We should not just focus on coding as a local optimization, but we should look at our entire software delivery lifecycle and try to see where AI can bring further value. Okay, so now I've shared a bit of the theoretical perspectives on what does it mean to build your foundations right, then which aspects of the software delivery lifecycle can you think about AI. Now let's try to look at a few practical patterns that we have seen help our teams as well as our clients. So let's start with a very common bottleneck in the early phases of a project, right, which is writing user stories or generating user stories. It's a critical task, but sometimes it can be slow and repetitive in nature, and the quality can be inconsistent from person to person, right? To tackle this, we have developed and experimented with an internal tool which sort of helps teams generate more consistent and well thought through user stories directly from raw requirements. But we have to remember that just like how we would train a new BA, we find that AI performs dramatically better through a structured thinking process. So just like how we apply that for AI-assisted development, we also have to apply it in other domains. So let's look at what you can see, what we mean by this. So as you can see on the slide, we built a workflow where we provide AI with 3 crucial inputs before even it generates anything, right? So firstly, we need to give AI a rich business context. We don't just give it the what, we have to give it the why, like what is the business outcome we are trying to achieve, who is our end user, what is the business goal. And in terms of guiding principles, we literally provide it with the definition of what a good story looks like. For example, the invest criteria that we wanted to use to guide its output. And thirdly, we provide it with a consistent template, right? So we give it the extract structure we want, the format we want it to follow, so that we have consistency across the stories that we are generating. And by providing this scaffolding, we notice that the quality and completeness of the generated stories improves significantly, and therefore you can start to have some time savings. But now this is not a silver bullet, right? I'm not saying that you can just put an AI tool and generate your stories tomorrow. We definitely still face challenges with occasional instability in the output and lack of sometimes getting the same results. So the key takeaway here is that for complex analytical work like requirements, you still want to rely on the human, but for simpler aspects such as just generating user stories, putting the acceptance criteria, you can start to use AI as a companion in that journey. So I want to give you a quick view of what this looks like. So this is a view of that tool where we'll give it a very simple requirement, but there is like already context provided by this tool so that it knows, okay, what's the project that we are working on, what's the business context for it to actually generate some stories for you. And what you'll notice is that it will not straight away go and generate story. It will first ask you for a set of questions to validate that it understands your requirement. Okay, do I need to think about scheduling? Do I need to think about other aspects of this particular problem? And then at the end, you'll also see that we have LLM eval integrated into the tool, which means that we use LLM to evaluate the quality of the story based on the criteria that we have specified. So let's take a look. So here we give it a simple requirement that I want to, as a sales manager, want to build this story, plan activities. It already has some context. Then it asks you a set of questions. Okay, what level of detail should I include? Should scheduling of recurring contacts be in scope? We say no, that's a future requirement. We further say, okay, we need to connect it to a customer ID. So you can take a look, validate that AI has got your requirements correctly. Then you ask it to generate a summary, right? So it generates a summary, it generates a list of acceptance criteria. Here it follows the given when then format. And then at the very end, you see we have a way to evaluate this user story. So is this user story good? And you see actually in this case, it's not too good. It says, no, the story might be not small enough, right? You might want to split it into various steps. So again, this just shows how you can quickly accelerate the work that our product managers and our business analysts have to do on a day-to-day basis. Again, to have more consistency, but at the same time, human review here is non-negotiable because we cannot just take the story and give it to our developers for building. Okay, so now let's say our user story is well defined, right? We are in our software delivery lifecycle, and now we've moved on to the phase where everyone thinks of AI, right, which is coding. And my colleagues and previous speakers, Wenbo, Chris, have covered a lot in this area, so I will not spend too much time on it, but the principles apply the same, that you want to think about breaking your task into smaller problems, you want to verify what the AI produces, you want to improve your prompting skills. Those are the key principles here when you're thinking of AI-assisted development. But let's move on to the next phase in our software delivery lifecycle. So next is around test case generation. So we all know that manual testing is a classic bottleneck. It's slow, it's repetitive and inconsistent. And this is again a possible fit for GenAI, right? An engineer can now generate rich test data through simpler and single prompts instead of spending hours coming up with just simple fabricated test data that it needs for testing. And AI can also go to the level where it can read a user story and instantly generate a list of test cases that the QA can consider, giving team a massive head start. The real value here is that it frees up the time of the quality analysts or your engineers for high-value exploratory testing, using their intuition to find the complex and real-world bugs that AI would not be able to find typically. Again, the same word of caution that it's not a magic button. You have to, AI can help you cut your time dramatically for routine tasks like generation of test data, validating. But when it comes to more complex and nuanced edge cases, you still want a human to be doing that. So it sort of gets you 70 to 80% there, but you still want the rest to be done by a human. Okay, so with that, let's move on to the next pattern, which is operations. And here usually is where I think most of the friction exists in organizations. So first, I feel like AI is a big win for observability and FinOps. Today, even when I'm on call, I feel like I'm drowning in data, right? There's so many logs I can look at, so many dashboards I can look at. And I feel like AI can potentially move out the noise and help identify the signal into one actionable insight, right? Identifying both the root cause of what could have happened and opportunities on how you can fix it. And this is what we tend to refer to as like a closed loop remediation. So let's imagine a scenario, right? It's 3 a.m. And an alert fires, right? The AI also gets the alert and so does the human, but AI already starts to diagnose the problem from the logs. And it can, in more mature cases, it can also get to an extent of identifying a more recent flag change that would have caused the issue. It also maybe generates an MR for you to tell you that, okay, this particular flag needs to be reversed or rolled back. And then your all-call engineer still has to wake up, but it doesn't have to wake up to, trying to find the root cause. They don't have to do that. They just review and then they approve it. And this is how AI moves your role from, being able to resolve your issues in production from hours to minutes. and shifting the human's role from trying to diagnose in the early hours of the morning to maybe being a reviewer and being able to accept the change. So again, here is where it's quite powerful. And I have one more bonus pattern for you, which is not strictly speaking in the software delivery lifecycle, but it's a big one that we are seeing our clients benefit from. And this is actually using GenAI in legacy modernization. So I'm not sure if folks here have any legacy systems or infrastructure. Yeah, you? Yeah. So some organizations, have those black box legacy systems that nobody really understands, but the caution is never to touch it or never to change it. The original developers have either left the organization or no longer work in that area. And the code is a mystery for most of the engineering teams, right? Like we see this a lot, especially in bigger industries that have been in market for decades. So GenAI is sort of a game changer here. It acts as this universal translator, allowing your team to get at least plain English explanations of complex legacy code without having to familiarize yourself with COBOL or some version of Java that was really old. But more powerfully, it can actually reverse engineer the entire system to generate some capability maps and dependency graphs that you never had, right? Like, because this information was just lost in that code. And this at least gives you a good starting point for your as-is blueprint of what this legacy system is all about. And it de-risks your entire modernization strategy because now it gives you a clear path for forward engineering. You know what the old system does, so you can design your newer system well now. And this is the for some organization, actually, this is the single highest value AI use case that we are seeing. Okay, so now we have seen all the powerful ways in which AI can be applied. But how do we know that our investment is clearly working, right? This is where I see a lot of organizations fail or maybe not making the right start. They get into measuring some of the metrics which may not be showing the real outputs, right? So they measure things like, as Venvo was sharing, lines of code which are generated by AI, or number of developers that are using a particular AI tool. But this actually tells you nothing about the business impact that AI is bringing and what's the ROI on it. So in my experience, you have to measure the outcomes and not the output to be able to understand that the investment that you are making on GenAI is actually reaping benefits. So the first one I recommend that when you start to think about metrics is to think about engineering excellence, right? So this is your foundational quality of your systems. This is the internal health of your system, your test coverage, your tech debt, your coverage ratio, your UAT violations. If AI is really helping you write better code, more consistent code, then these leading indicators of quality should definitely improve. Next, we also want to measure deployment excellence, right? So this is really your throughput. The gold standard here, of course, I'm sure everyone has heard of it by now, is the DORA metrics, right? So you have your deployment frequency, your mean time to repair, your change failure percentage, and your lead time. These measures talk about the speed and the stability of your system. If AI is really reducing friction and shortening your feedback loops, then your lead time must go down, right? So that's another important metric when you're thinking about measuring your ROI on AI. And lastly, I think this is the most important, even more important than DORA metrics, is your business outcomes, right? Who cares actually if you're deploying 50 times a day if the customers are unhappy or the revenue is down? This is really the why we build software. So are we improving customer engagement? Are we improving revenue? Are we reducing the time to market for a feature that customers are begging for, right? Those are the metrics that you really need to worry about. And when we think about GenAI and its ROI, the goal is not to use GenAI, right? Like we always have to remind ourselves of that. The goal is to improve the business, is to bring more revenue. And we use the first two levels to prove how AI is helping with the third and the final goal, right? So usually this is how I would think about metrics and how you measure your outcomes. Okay, so let's bring this all together. I've shared a few concepts here with you. So we started with establishing that the hype around AI-assisted coding is real, but it's a local optimization, right? The real problem is also attacking the other 60% of the bottlenecks and the friction that you have in your organization that actually delays the entire system. You need to fix the system, only then you can amplify it with GenAI, and this is how you will get real business value. So therefore, you cannot buy your way to productivity. You cannot buy some tools, buy some tokens, and get productivity. AI is an amplifier, but your engineering foundations need to be right. Your first investment must be in those engineering foundations, your platform, your DevX, your operating model, your domain-driven architecture. Those things have to be right. Then you can apply AI holistically, right? You can use it as a force multiplier to build those foundations and to attack friction at every single point, from planning, testing, all the way to deployment and operations. And finally, you measure what matters, right? So don't track lines of code generated, track your DORA metrics, prove that your system is going faster, prove that you're able to bring more value, it's more stable. And more importantly, your business outcomes, right? Are your customers happy? Are you getting the revenue that we are promising from an engineering organization? So fix the system and then amplify it. That is how you can go beyond, the hype and actually get to some real ROI. So with that, I've come to the end of my presentation. I hope you enjoyed the session and there's something for you to take away.